The undeniable fact of climate change has revealed its prominence today, with scientific studies showing the major effects that it has had on the living and physical world. With an increasing anthropogenic impact on the environment as the world population grows, climate change's effects have become more pronounced and more damaging in recent years. One of the most destructive and harmful impacts of climate change is an increased intensity of cyclonic storms, and this will be the main focus of our presentation today. So, what is a cyclonic storm? Well, a cyclonic storm is a circular, rapidly rotating storm with immensely destructive tendencies. They tend to generate around the equator or tropics and rotate counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. In addition, cyclonic storms can come in several different intensities and categories, ranging from a depression at 31 to 50 kilometers per hour to a super cyclonic storm at greater than 221 kilometers per hour. Cyclonic storms can be called different things based on where they are occurring. They're called hurricanes when being identified in the Atlantic Ocean, typhoons in the Western Pacific Ocean, and cyclones in the Indian Ocean. After a cyclonic storm occurs, a phenomenon called a storm surge happens, and there is an increase in sea levels of the affected region. Strong winds push water into the shore, which can lead to immense flooding for miles along the coastline. This flooding could be detrimental to civilians and ecosystems, which will be covered in later slides of this presentation.
So what actually causes a cyclonic storm? So differences in air pressure push air around. This happens usually over warm ocean waters near the equator. To form a cyclone, warm, moist air over the ocean rises upward towards the surface. As this air moves up and away from the ocean surface, it leaves less air near the surface. So as the warm air rises, it causes an area of lower air pressure air below it. So then as the higher air pushes into the low air pressure area, the new cool air becomes warm and it rises too. The cycle continues. It becomes like a positive feedback loop. The air continues to speed up until it hits 63 kilometers per hour, and that's when it becomes classified as a tropical storm. Then after it keeps on speeding up until it hits 119 kilometers per hour, and that's when it's classified as a cyclonic storm, also known as a hurricane. And as you can see, this heavily relies on heat, which is why it usually forms around the equator. And so as it continues to speed up too, it forms a little region called the eye. As you can see, the diagram is right in the middle. And the eye is actually, ironically, the calmest part of the storm, despite being right in the center. However, the eye wall, which is surrounding the eye, is considered to be the most dangerous part of the hurricane, which is pretty ironic because how close they are to one another.
What's been happening to cyclonic storms in recent years? Well, the intensity and the frequency of these cyclonic storms have increased greatly. According to the graphic on the right, Atlantic-based hurricane counts, around 1851, there were 4 cyclones counted. However, in the years around 1999 and 2000, there are 9 cyclones counted, which is the highest peak on the graph and more than a 100% increase in the frequency just in the Atlantic basin. Intensity has been increasing as well. Using the intensity around 1950 as a base, we can see that the intensity of recorded cyclonic storms has increased by 90%. But predictions model the increase in intensity of cyclonic storms to almost 300% by 2100. Why is this happening? Well, as noted in the previous slide, high temperatures are often the catalyst for these cyclonic storms. So the warming of oceans caused by climate change is increasing the frequency of these cyclonic storms and the intensity.
These cyclonic storms have a major impact on the people and wildlife. For people, these storms cause mass fatality and injury to civilians in the storm itself and in the storm surges post the storms. The storms cause major flooding in areas. This can damage infrastructure by cutting power lines or damaging generators. It also harms efforts by ambulances and rescue teams to help people. This is especially prominent in third world countries where not as many resources are there compared to first world countries. Wildlife is also harmed during this process due to habitat damage. And this impact is exponential as support is mainly given to the people impacted and not the animals. In a case study on hurricanes in the US, Hurricane Katrina, one of the most well-known hurricanes in the U.S., has dealt $160 billion in damages, 1,833 deaths, and had a storm surge of 25 to 28 feet higher than normal sea level. Ike in 2008 had a $24.9 billion in damage and a storm surge of flooding of around 15 to 20 feet higher than normal sea level. In the recent 2017 hurricane season, 10 of the 17 tropical storms that hit the American coast were hurricanes. $265 billion in damages were a result of these hurricanes, and 251 people lost their lives. In a case study on the Bay of Bengal in India / Bangladesh, here we have two diagrams. The left diagram is the months of May to June in 1990 in the Bay of Bengal. And on the right, we have two diagrams. We have the diagrams of September and October. September at the top, October at the bottom, May at the top on the left, June at the bottom on the left as well. So now these diagrams on the left side show what actually happened, what the actual paths of the hurricanes were, what actually occurred. While on the right next to them, they have simulations that what was predicted of these hurricanes. Now this is extremely important in retrospect because here is the simulations for the 2071 to 2100 storms, track of hurricane storms in the months of May, June, September, and October. These simulations show that the future storms will be much more erratic and much more intense in these upcoming time periods. And this has major implications as the Bay of Bengal is home to millions of people in Bangladesh and India. And with the country's populations only increasing, the storms are only going to continue to cause more damage and harm more people in the area.
After analysis of all of these case studies, and they show the trend of increasing intensity of cyclonic storms, we can really see how important it is to tackle these problems. Because tropical storms are usually caused by climate change and the increased intensity can be almost solely attributed to climate change, we can really look at tackling climate change as being the way to tackle these storms. It's only going to continue to grow and continue to become more intense until it hits the point where we can't do anything about it. So we really have to do something about these storms. It's going to affect a lot of people and going to affect a lot of animals and potentially destroy entire cities. We really have to do something about this. Thank you.